This question is also based on the projectile motion, and in that also it is particularly a case of projectile projected with a horizontal velocity. So the question is, a pressure tank issues water at A, so this is the point A, with a horizontal velocity u as shown in the below figure. Yes, this is the horizontal velocity. For what range of values of u will water enter the opening CD? Now, when the term range comes, means there are two values. Okay, then only we can say that it's a range. Okay, so means we have to find two u values for the given equation so that water enters the opening CD. Okay, that is, see what happens is, if the velocity is more, then what happens, immediately after the release the water is going to strike the wall here. Okay, so if the velocity of the water is less, then what happens, it will take time. Okay, moves in this way and it strikes after the opening of the wall. Okay, so to facilitate that water enters the opening CD, we have to maintain some velocity. Okay, then only water will enter the opening CD. If you look into the figure, there are two cases. That is, for the first case, that is the water has to travel a vertical distance of 1 meter. Okay, I am calling this as H1, so that water will enter the opening from nearer to the point through the point C. Okay, this is the first case. That is, if the water travels 1 meter height along vertical direction, then it is possible to enter the opening. Okay, and in the other case, the water has to travel a distance of 1 plus 1.5 meter. That is 1 plus 1.5 meter. It is 2.5 meter. Either it has to travel 1 meter distance or it has to travel 2.5 meter distance, then only it's possible to enter the water droplets through the opening. So I am writing this as H2 here. Okay, so here there are two cases. Case 1 is where x is 3 meter, it is given here. So both for the case 1 and case 2, x is 3 meter, and what is y? Y is h1 and h1 is given here, that is 1 meter. Okay, I have to find the velocity so that the water enters the opening CD. So now we have the equation, that is distance traveled is equal to velocity multiply with time. So here this velocity is the initial velocity. So distance traveled is x here. X is equal to velocity multiply with time, and this x is given, that is 3 meter, and what is v? V, or it is u here. Okay, so they have denoted that as u only. We shall also denote that with u. So time required is, we have the equation 2h upon g here. So if I substitute the value of h here, so here it is u as it is, and it is 2h. H is, for the case 1, h is 1 meter upon 9.81, and if we solve this one, we get u as 6.644 meter per second. That is, if I release the water with this velocity, it is going to enter the opening CD. Okay, it is going to enter the opening CD. Then for the case 2, x is 3 meter and y is h2, that is 2.5 5 meter. So again distance traveled is equal to, it is distance traveled is equal to velocity multiply with the time. So this velocity is again the horizontal one, so it is x is equal to u multiply with time. X is same, that is 3, and what is u, that we have to find, and t can be written as 2h upon g, and for the case 2 h is 2.5 meter. So it is 3 is equal to u multiply with 2 multiply with 2.5 upon 9.81. So if we solve this one, we get the value of u as 4.201 meter per second. So now we have obtained two values for this question, that is one as u is equal to 6.644 and u is equal to 4.201 meter per second. So I can write now the range of velocities should be 4.201 to 6.644 meter per second. Then only the water will enter the opening CD. If it is more than this one, then definitely it will strike above the point C. If it is less than this 4.201, it will strike below the point D. Yes, this is the solution.